Hello everyone, my name is Chi. Today, I want to educate the audience about ENERTECT battery monitoring systems from GPS GC. ENERTECT, an intelligent and innovative UPS battery monitoring system, is the brainchild of Global Power Source Group that has dominated the power backup industry since 1988. The synergy of the in-house software development team combined with battery and UPS field level experience has contributed to the success of ENERTECT. ENERTECT monitoring system is used for large-scale power backup installations where system availability is critical to successful business operation. Most failures occur due to improper UPS and battery maintenance. ENERTECT monitoring system allows you to maintain a safe and secure system with real-time monitoring, which will minimize the probability of any failures and optimize the life of the batteries. Our monitoring system is designed in accordance with IEEE battery maintenance recommendation. ENERTECT acts as a protector of your critical infrastructure. You can rely on our technology to shield your operation and data from the vagaries of the environment. There are certain generic reasons why batteries fail. The following problems, most of which can be controlled by the user, are the most common causes of premature battery system failures. Excessive cycling. The cycling capability of a lead-acid battery depends on the depth of discharge. Excessive depth of discharge may lead to premature failure of batteries. Post-seal leakage and loose intercell connections. A leaky post seal allows acid to migrate up to the post or intercell connection area and cause a connection problem. Loose intercell connections and improperly tightened intercell hardware means very high resistance connections. Low float voltage. This causes sulfate crystals to form on the plate surfaces. Sulfate crystals that harden over a long period of time will not go back in solution when proper voltage is applied and therefore cause permanent loss of capacity. This problem shows up as an increase in cell resistance. High float voltage. This causes excessive gassing of hydrogen and oxygen, and these lead to dry out and potential thermal runaway in VRLA battery. High float voltage also causes shedding of active material from the positive plates. All these problems increase the internal resistance of the battery. High temperature. This causes loss of battery life. Life is cut in half if operated at greater than 33.5 degrees Celsius. High temperature also increases float current, which results in dry out and thermal runaway in VRLA battery. These problems lead to increase in cell resistance. Over discharge. This causes abnormal expansion of plates, which can lead to permanent damage and recharge problems. This can happen in lightly loaded UPS systems that experience an extended power outage. A fully discharged or nearly fully discharged battery will be damaged and possibly ruined if not recharged within 24 to 48 hours. We believe that the best way to address battery and UPS problems is to monitor, detect, correct, and prevent any failures from happening. Why monitoring is necessary? There are many arguments for monitoring, but the most obvious reasons are increased system reliability. Elevating system reliability by eliminating power outages is obviously a huge cost saving. Sometimes, spending money to save money is a tough argument to prove within the company. But when the cost of failure is compared to the cost of monitoring, it almost seems irresponsible not to consider it. How can monitoring improve system reliability? Monitoring improves system reliability by detecting battery problems at an early stage before they can cause an abrupt system failure. How are problems detected? Problems are detected by measuring the internal resistance of each battery in the system. The resistance of a battery has been proven to be a reliable indicator of a battery's state of health. The only other method for testing a battery's condition is to perform a capacity test. No one can argue the effectiveness of a capacity test, But unfortunately, because of its cost and other site accessibility issues to perform, many users will not load test their batteries. The chief advantage of a resistance test is that it can be performed automatically without any test personnel present. Cost savings. There are 3 ways that monitoring can provide cost savings that readily offset the initial cost of purchasing a monitor system: by reducing maintenance time, by optimizing battery life, and by reducing test costs. Reducing maintenance time. The time required to maintain the batteries in a typical setup, in accordance with IEEE standards, is at least 25 hours a year. Most of these hours can be saved by using a monitor, and the hours saved will give you a return on investment in 2 to 4 years. Optimizing battery life. Battery life is greatly affected by the ambient temperature, excessive cycling, and float voltage. A monitor that assists the user in taking corrective action against any out-of-tolerance condition can prevent premature aging of the batteries. Many users only obtain 50 to 80% of the realistic life of their batteries. Reducing test costs. Every new battery system must be acceptance tested with a capacity test to prove that it will be able to perform when needed. It is also prudent, especially in applications where financial or safety issues are involved, to perform periodic capacity tests to determine where the battery is in its projected life. The cost to perform these tests is several $1,000s per test and requires a lot of setup time. A permanently installed monitor that can log data during a scheduled or unscheduled discharge eliminates a substantial amount of these costs. Safety. A permanently connected battery monitor reduces the need for maintenance personnel to come directly in contact with the high voltages present in most battery systems. If the monitor identifies a problem, then the battery may have to be accessed by maintenance personnel. In the case of a problem, however, the battery will typically be disconnected from the load and the charger, thus reducing the exposure. UPS systems that have batteries installed in a cabinet are especially hazardous to work with, since there is a very little space to access the battery terminals for routine maintenance measurements. And besides the personal safety issues, there is also always the danger of someone accidentally creating a problem that shuts the system down. What parameters must be monitored and how ENERTECT helps? Some battery parameters are monitored to verify the battery is being operated in an environment that guarantees optimum life, and some are monitored to track the state of health of the battery. For a monitor to achieve its main objectives, it must, as a minimum, monitor the following parameters. Cell voltages, to verify all cells are charging correctly. Internal resistance, to verify the state of health by identifying low-capacity cells. Battery temperature, to verify cell behavior during charge and discharge. Overall string voltage, to verify the charger has been set correctly and operating properly. Charging current, the float current drawn by a battery can be useful in VRLA batteries to detect thermal runaway conditions. Discharge current, the current delivered by the battery during a discharge is used to calculate the capacity of the battery. It is also useful in parallel string applications to see how the strings share the load. Load cycle, to check the number and depth of discharges. This information is used to project battery life and settle warranty issues. Ambient temperature, to verify the temperature environment is at or near optimal temperature for long life and maximum capacity. Hope ENERTECT BMS shall act as a real-time doctor for your batteries and thus ensuring preventive measures for increasing your battery life. In case of more questions, please feel free to connect us at info@enertect.com. Thank you very much.